Hello, welcome back once again. Today we have this interesting problem. I think it's an Olympiad math and we're asked to solve for all possible values of x that satisfy this original equation. So how can we solve this problem? So we have three cases to consider here. Let's begin with the first case. So what is our equation? Our equation is x squared minus 4 raised to the power of 3x minus 6, that this is equal to 1. So let's start with our case 1. For our case 1, we know that a raised to the power of 0 is equal to 1, provided that a is not equal to 0. So what is this trying to let us know? This is trying to let us know that if the power of this base x squared minus 4 is 0, then it is equal with the right hand side. Therefore, this implies that 3x minus 6 needs to be equal to 0. So add 6 to both sides, so we get 3x is equal to 6. Divide both sides by the coefficient of x. So this will cancel this, and from here we get x is equal to 2. Okay, I agree. This indeed satisfies the equation because it will make the exponent 0. Therefore, x squared minus 4 to the power of 0 will give us 1. Right? Okay, cool. Now, our case 2, that is our second case. So what should be our second case? We know that 1 raised to the power of n will always be equal to 1, no matter what n is. So what is it letting us know? We're going to let the base equals 1, because 1 raised to the power of that power, 3x minus 6, will also give us 1, which implies that x squared minus 4 is equal to 1, right? So from here, we have that x squared is equal to 4 plus 1, because 4 is negative. So if it's crossing over to the right hand side, that will become positive. So we get x squared is equal to 5. We can take the square root of both sides. We get x is equal to plus or minus the square root of 5. Does this satisfy our equation? Yes, of course, this satisfies our equation, because x squared will give us 5, and 5 minus 4 is 1. 1 to the power of 3x minus 6 is equal to 1. So this is a solution, right? And we're done now. Oh, wait, I think 2 is not a solution. That is why this problem is really very interesting. I'm very sorry for this. Yes, of course, we know this 2 will make the exponent 0, and this way as well make the base x squared minus 4 0, thereby getting 0 to the power of 0, which is not equal to 1, which is undefined moreover. So therefore 2 is not a solution, so this is discarded. But if we check for plus or minus root 5, that will satisfy our equation, because that will just make the base 1. If the exponent is whether rational or irrational, 1 to the power of an irrational number is 1. 1 to the power of transcendental number is 1. So x equal to plus or minus root 5 is a solution. Okay, so let's go to our final case. So we have 3 cases. So this is our final case. And what is that? We know that negative 1 raised to the power of m is equal to 1. If and only if m is even. Hope I'm making sense. So if m is even, then negative 1 to the power of an even number is 1. So what is it letting us know? This is letting us know that the base x squared minus 4 can also be equal to negative 1. So here, add 4 to both sides, we get x squared is equal to negative 1 plus 4. We get x squared is equal to positive 3, right? So from here we're going to take the square root on both sides, so we get x is equal to plus or minus the square root of 3. Does this satisfy our equation? This will only make the base negative 1. What about the exponent? And what is the exponent? 3x minus 6. Oh, the exponents will be irrational. Negative 1 to the power of an irrational number is not equal to 1 but complex. I think so, right? Therefore, this is not a solution as well. Imagine. It's a very nice problem, right? So what is our solution? We come up that x is equal to plus or minus the square root of 5. This, we have only two solutions. Please, if you know you enjoyed this video, kindly support my channel by subscribing. Subscribe, turn on the notification bell for my next videos. Bye.